The ideal version of you, the version that is successful, that is in a loving relationship, that is healthy and thriving, might already exist. In fact, multiple versions of you might already exist, and your job is simply to select the one you want to experience. This might sound hard to believe, but in today's video I'm going to explain how science inspires this idea. Specifically, I'm going to explain how parallel versions of you relates to quantum physics. My name's Georgia. I have a master's degree in consciousness, spirituality and transpersonal psychology, and one of my favourite things to do in my free time is explore the links between science and spirituality. Now, one of the most interesting links that I see is between the law of attraction and quantum physics. In manifestation, we talk about some ideas which seem very mystical, like the idea that multiple versions of you already exist. But there's a very interesting parallel to this within quantum physics. So in today's video, I'm going to be exploring the concept called quantum superposition. Whilst this concept doesn't prove the idea of multiple realities in manifestation, it offers a very intriguing correlation, and it might help make manifestation seem just a little bit less woo-woo. One way to view manifestation is that you're not creating a new reality entirely from scratch. Instead, you're selecting one that already exists. The idea is that every version of you, the version that is rich, successful, happy, already exists, at least in potential form. By aligning with these versions through your thoughts and your actions, you can shift into the reality you want to experience. You might have heard of quantum jumping. The idea of quantum jumping is exactly this, that you can jump from your current reality to the reality that you desire, essentially shifting timelines. Now, despite its name, quantum jumping doesn't refer to any recognised scientific process, but it does link to the quantum physics ideas we're going to explore in this video. So the key question is, could these alternate versions of you or your reality already exist? Well, there's a very intriguing parallel to this idea called quantum superposition. The idea is that quantum particles like electrons or photons can exist in multiple states simultaneously. Now, if we contrast this to classical physics, which is just the physics of this level that we exist at, of macro scale objects, at the classical level, objects are always in a definite state. If we take a ball, for example, a ball is either stationary or it's rolling. It's never in two different states at once. Quantum physics, however, turns this on its head. Quantum particles don't seem to occupy any definite state until they are measured. Instead, they seem to behave as if they're in multiple states at once. Now, one of the best demonstrations of quantum superposition, which might help you understand it a little bit more, is the double slit experiment. What happens in this experiment is we fire quantum particles, such as electrons, through a wall that has two slits in, and behind the wall there is a screen. And what happens is, when electrons are fired through these two slits, and when the experiment is not being measured, we get an interference pattern on the back screen. And this happens even when particles are sent through one at a time. So it's as if each particle has gone through both slits at once and interfered with itself on the other side to create the interference pattern. So it's like the particles were in two places at once. Think of if a wave went through two slits. A wave would split into two, so it would technically go through both slits at once, and then interfere with itself on the other side to create an interference pattern. An interference pattern is something that is typically created by waves. But in this experiment, it seems like quantum particles are behaving in the same way. It seems like the particles really are going through both slits at once and interfering with themselves. It's like they're in a superposition of going through both slits at the same time. Now, an even more fascinating part of this experiment is that when the experiment is measured, so when there is an atom detector present, the interference pattern disappears. So suddenly the particles start behaving like classical particles, like we would have expected in the first place. They only go through one of the slits. In other words, the superposition disappears. The particles behave like they are in one definite state, one definite location. So it's only when we don't measure the experiment that particles behave as if they're in multiple states at once. Now, I do have to note here, we don't technically know what state the particles really are in when we're not measuring the experiment, because as soon as we do measure, they start behaving like particles again. So we have no way of seeing what state they're really in when we're not measuring. Physicists use something called a wave function to describe the state of the particle when we're not measuring it. Now, the wave function is essentially a mathematical construct, and it describes the probabilities of finding the particle in a particular place or state. So the wave function describes all of the possible states that the particle could be in. It essentially describes a superposition. So the critical question here is superposition literal? Can a particle really be in two states at the same time? Now, this question is a little tricky to answer because it kind of depends on what interpretation of quantum physics you subscribe to. Some physicists believe that the wave function represents a real physical wave. In this view, the particle really would be spread out across space, and so it really would be in multiple states or locations at the same time, in a wave-like form. This interpretation does make it a little easier to explain the interference pattern in the double slit experiment. However, some physicists do believe that the wave function is simply a mathematical tool and doesn't represent any physical wave at all. Here, the particle isn't physically in two places at once. The wave function simply describes the probabilities of the particle being in a particular state. Either way, something very strange is happening at the quantum level. A particle's state doesn't seem to be determined until it is interacted with. This mirrors the idea in manifestation that multiple potentialities exist until we select one through our thoughts, our feelings, and our actions. You could say that choosing your reality in manifestation is like collapsing the superposition into one state, into the state that you desire. Now, it's important to clarify here that it's a lot easier to see superposition as a metaphor for manifestation, because superposition obviously applies at the quantum level to quantum particles, not to macroscopic things like us and our lives. And there is actually a very famous thought experiment which demonstrates the difficulties of applying quantum superposition to the macro scale, and that is Schrodinger's cat. Erwin Schrodinger designed this thought experiment to demonstrate the strangeness of quantum superposition. And what happens in this thought experiment is essentially we have to imagine a sealed box, and inside that box we have a cat, a radioactive atom, a Geiger counter, a hammer, and a vial of poison. If the Geiger counter detects radiation from the radioactive atom decaying, then it triggers the hammer to break the vial of poison, killing the cat. Now, according to quantum superposition, the atom can be in a state of decaying and not decaying at the same time, which means the cat would be both dead and alive at the same time, which is obviously very strange. So superposition works very well at the quantum level to explain things like the interference in the double slit experiment, but it becomes very strange when we apply it to macroscopic objects like a cat. Most physicists agree that decoherence prevents macroscopic superpositions. So decoherence occurs when a quantum system interacts with its environment. This causes it to lose its quantum behavior and to occupy a single definite state. So this would explain why superposition would happen at the quantum level, but why we wouldn't see dead and alive cats at the macro level. Now let's leave that thought experiment behind for a second and go back to the quantum level. I want to look at what causes a superposition to transform into a single state. What causes one possibility to be selected from the superposition? Now, this concerns a phenomenon called the observer effect. Now, I've already hinted at the observer effect throughout this video. What it means is that in quantum physics, a measurement causes a superposition to collapse into a definite state. So we already saw this in the double slit experiment. When the experiment is not measured, the particles create an interference pattern as if they're in multiple states at once, as if they're going through both slits at once. However, when that experiment is measured, they suddenly behave like particles again. So that superposition collapses and the particles only go through one of the slits. So in the double slit experiment, using an atom detector, which is akin to the measurement, causes the superposition to collapse. Now, if we look at Schrodinger's cat again, in this experiment, the idea is that when the box is opened, that causes the decaying atom to take one state, either decaying or not decaying, and so the cat would also be in one state, either alive or dead. So imagine that the act of opening the box is the same as taking a measurement. That would be how the observer effect would apply in Schrodinger's cat. Of course, as we already discussed, decoherence would prevent the cat from being in a superposition in the first place, but if it didn't, imagine that the act of opening the box is like taking a measurement. In manifestation, the observer effect could be like focusing our thoughts and actions on one specific outcome. By focusing your attention, you could metaphorically collapse potential into one definite state, your desired reality. Scientifically, the observer effect refers to measurement, not conscious thought, but could consciousness play a role? I now want to look at two interpretations of quantum physics which might shed further light on how the superposition collapses, because ultimately, when it comes to the phenomenon that we see in the double slit experiment, no one really knows what is going on, so there are many different interpretations. Now, one of the interpretations is the von Neumann-Wigner interpretation, and this interpretation does suggest that consciousness plays a role in collapsing that superposition. This interpretation implies that a conscious observer might influence quantum events by causing a superposition to collapse into one definite outcome. So this interpretation is often used to back up the idea that our consciousness might have an influence over physical reality. This interpretation is speculative. Like we've seen in the double slit experiment, it seems that a measurement can cause this to happen, but the question is whether or not consciousness could also have this effect. If consciousness can have this effect, then it might provide a basis for how manifestation techniques allow us to choose a reality out of multiple possibilities. Now, a second interpretation which doesn't involve consciousness but really hinges on this idea of parallel realities is the many worlds interpretation. This interpretation proposes that all possible outcomes of a quantum event occur in separate branching universes. Instead of collapsing the wave function or the superposition, reality splits into parallel worlds for each potential outcome. So if we go back to the double slit experiment, for example, the particle can either go through slit A or slit B. Now, instead of the superposition collapsing and it going through either one of those slits, instead reality would branch into two parallel realities. In one reality, the particle would go through one slit, and in the other reality, the particle would go through the other slit. Now, if we go back to Schrodinger's cat thought experiment, the superposition of the radioactive atom being either decayed or not decayed wouldn't collapse into one of those options. Instead, reality would split, so we would have one reality where the atom has not decayed and so the cat is alive, and then we would have a second reality where the atom has decayed and the cat is dead. So the many worlds interpretation aligns with this idea that alternate versions of you exist in parallel realities. Now, I do have to note here that according to the interpretation, it's not an infinite number of parallel realities. The number of realities is limited to the number of options within the superposition, so it's constrained by the wave function. But it does suggest that there are a number of parallel realities, and I would assume a very large number, with different outcomes. So maybe there really are parallel versions of you in parallel realities. Now, there's no mechanism in the many worlds interpretation for shifting between different realities. However, some people suggest that manifestation involves selecting a reality and shifting into it, akin to quantum jumping. So quantum physics, and specifically quantum superposition, offers some really fascinating ideas about possibilities and parallel realities. Even if it's not literal and it doesn't prove manifestation, superposition definitely offers a very powerful metaphor for it. Just like how a quantum particle doesn't exist in any definite state until it is measured, your life similarly holds multiple possibilities, and you get to select the one that you want to experience. Now, I understand that everything we've talked about in this video is a bit out there, so if you want a less speculative explanation for manifestation that involves neuroscience, you can watch this video here. For now, thank you so much for watching. I really hope you enjoyed this video and got value from it. If so, please give it a thumbs up, and I hope to see you in the next video.